Hi all, we're going to start up with lesson 14 today, and in 14a we're talking about body mass index. Unit 14 in general, we're talking about formulas and how you use those formulas and how you manipulate those formulas to do what you or to use for what you need them to be used for. And so we're going to start with BMI, which is body mass index, and it's a measure of body fat based on your height and your weight. Now, your actual body mass index, or your percentage of fat in your body, can actually be measured better with some other indicators, but this one is quick and easy, and we have a formula for it that we're going to use. But just so you know that this formula isn't perfect, there's ways using a tape measure, which they actually show in the picture here, where you can measure different parts of your body and use that to calculate your body mass index. And then there's also the best way is to actually, I believe, to submerge your body in water and find the difference in the displacement or something like that. So there's other better ways to do this. So if you throw your own height and weight into this and it doesn't come out to what you think it should be, or how you've measured it with a more accurate way recently, don't be too surprised, but it's fairly accurate. It's not horrible or anything. So it says that BMI is considered a better predictor of your health than just your weight, and we're supposed to jot down our ideas about why this statement is true and share. Since we don't have other students to share that with, I'll just mention some of the things that are typically brought up. Your weight as a only indicator of your health isn't good because of the fact that muscle weighs more than fat. So somebody could be in really good shape and have a lot of muscle, and they could weigh more than what the charts say is typical, but still be in good health. And so that's the biggest idea, is that just because your weight doesn't tell you how your body is built, it only tells you how much you weigh. So there are times where someone could appear to be overweight when they're really not. So we'll just kind of jot that down up here. So we said that muscle weighs more than fat. Okay, so now let's go ahead and get into the actual formula here. So to calculate BMI, the formula that is used, is that BMI is your weight divided by your height squared times 703. So we're just going to get some different people here and put this in. A couple things that we want to note is that weight is in pounds and that height is in inches. So we can't put in kilograms or anything like that for weight. We have to put in pounds, and for height we have to put in inches, not feet. So we're going to have to change what they give us. So we're going to start off with Joe, who's 5 feet 10 inches tall, and we're supposed to substitute his height into the formula. So we're going to simplify the formula so that it can be used for Joe. So BMI for Joe equals whatever Joe's weight is, and I'm just going to put a W instead of the whole word, divided by his height squared. But his height is 5 feet 10 inches tall. We need to get that into just inches. So remember that 1 foot equals 12 inches. And so 5 feet times 12 inches per foot would get us 60 inches. So 5 feet is 60 inches, and then we're going to add 60 inches for the 5 feet, plus then 10 inches because he's 5 foot 10, not just 5 foot. So Joe in inches is 70 feet tall. I'm sorry, 70 inches tall. So we're going to put that number here, and remember in the formula it says to square it. So it's 70 squared times 703. So his BMI is W divided by 70 squared is 4,900. That'd be 70 times 70. And then times 703. So it says what we have here is we've created a new formula that applies only to people who are Joe's height. What are the only variables that remain in your new formula? So this is a formula that anybody that was 5'10" could use, because this is going to remain the same if they're 5'10", this 4,900 here on the bottom from the 70 inches. And so the only variables that remain now are weight, which is what you would typically put in, and then you would get back your BMI. We actually could, if we wanted to, we could change this right here. I'm going to write this down, but then I'm going to take it out because I'm not really fond of this method. But we could take 703 and divide it by 4,900 because it's on the bottom. And we could write it as 0.143. That's 703 divided by 4,900 W. And we could just multiply this times the weight, and then that would work. I prefer to leave it like this and just divide and multiply rather than switching this to one number. But if you see that somewhere in the homework, or they ask you to do it in the homework, you'll know what they mean. So to get that, they just took 703 and divided it by 4,900 because this is on the bottom and it's a division. So that number could be placed in front. But I think that's a little confusing for some folks, and I don't feel like it's that much more helpful than just doing this single or these two quick calculations. So the variables that remain are weight and BMI. So using your simplified formula now, we're supposed to calculate Joe's BMI if he weighs 175 pounds. So if he weighs 175 pounds, his BMI would be 175 divided by 4,900 times 703. And if we calculate that, 175 divided by 4,900, and then I hit equals, and then I take that times 703, and I get that his BMI is approximately 25.1. It comes out to be 25.107, so 10 would round to 0.1. If we wanted to round it out to a second spot, it'd be 0.11 because the 0 has a 7 after it. So it's 0.10714, so on and so forth. So if we wanted to round it to one place, like I did, you're just going to say 25.1. If you wanted to round it to the second spot, you'd look here to the 7 and you would say 25.11 because a 7 would round that up. But I'm going to leave it with as 25.1. I'm just going to round it to the 10th place. So how does Joe's BMI change if he gains 10 pounds? So we're going to recalculate this. And if he gains 10 pounds, so plus 10 pounds, we would get 185 divided by 4,900 times 703. And 185 divided by 4,900 times 703. And we get about 26.5. So when he gains 10 pounds, his BMI, according to this formula, goes up by 1.4, from 25.1 to 26.5. If he loses 10 pounds, not from the 185, of course, because that would get us right back to the 175. They mean from the 175 if he loses 10 pounds. That would put him at 165 divided by 4,900 times 703. And that would put him at roughly 23.7. So obviously if his if his weight goes down, his BMI goes down, and if his weight goes up, his BMI goes up. So the next question asks, discuss with your group, or says discuss with your group how you arrived at Joe's BMI value. For example, did you multiply, add, subtract? What did you do first? Outline the steps you took. since we don't have a group, obviously I'll just have to discuss this with you, but basically, as I said up here, you could have taken it times that single number, but if you leave it as the two separate parts, you'll want to divide and then multiply by 703. So whatever the weight is, divided by the 4,900 times 703. And you could use the 70 squared. I mean, you could do 175 divided by 70 squared times 703 on your calculator. And if it's a scientific calculator, it'll handle the order of operations okay for you and do the square before it does the division. And so those are the steps that we took to get that. So let's move on to section B. So in 14B, we're going to continue working with the target weight, or I'm sorry, with the BMI formula, and we're going to be talking about target weight. Now we're going to start with a conversation here that's really, really important. It asks if you have ever seen a video running backwards, and it says what happens during that video. For example, if the original video showed a person opening a door, getting into a car, starting the car, what would the reversed video look like? Well, in the reverse video, instead of in the original video where you had open the door, get in, and start, when you rewound it, it would just go entirely backwards. Okay, so it would start, then it would look like, or I'm sorry, it would look like they were unstarting the car, like turning off the car. Then it would look like they were getting out, and then it would look like they were closing the door. So it would undo everything that was done, but it would do it from the last thing back to the first thing. This is really important when we're talking about algebra, and if you've had any algebra and nobody's ever explained this to you, this might be something that's helpful to you. In the order of operations, when you're working a math problem and you're just calculating something. So order of operations is for when you're calculating something. So you have an expression, it has a bunch of numbers in it, and you have to calculate the answer. During the order of operations, the first thing you do is you do parentheses. Then the next thing you do is you do your exponents, your powers. Then the third thing you do, and I've heard hundreds and hundreds of times people call this PEMDAS, and I don't like it called PEMDAS at all, because that makes it sound like there are 1, 2, and you write down, I'll write down PEMDAS, but then I'll erase it, because I don't like it. So when you see PEMDAS, it looks like there's 6 steps in the order of operations. But that's not the case. There is not 6 steps in the order of operations. It's not parentheses, then exponents, then multiply, then divide, then add, then subtract. So I'm going to write this a different way. It's parentheses, then exponents. The third step is multiply and divide left to right. So if you were coming across a division, say, and it was before a multiplication, you would still do it first because you do it from left to right. Any multiplication or division that you see, left to right. You're not supposed to do all the multiplication and then come back and do all the division. You're supposed to do any multiplication and division that you see from the left side of the problem to the right side of the problem. Well, if you think of PEMDAS, you think you're supposed to go through and do all the multiplication, then go back and do all the division, and that'll mess the problem up. So if you've had problems with order of operations in the past, that might be why, is because of what I think is a very poorly created acronym for the order of operations. The next thing after multiply and divide left to right is the same thing with add and subtract from left to right. Again, you don't do all the addition and then come back and do all the subtraction. You go from left to right in the problem, and any addition or subtraction that you see, you do as you go from left to right. So these two operations are on the same level, and these two operations are on the same level. So there's really just 4 steps to the order of operations, not 6. I prefer the acronym, not acronym, but the little sentence to help you remember it. Please excuse my dear Aunt Sally. And I like this better because even though it's kind of silly and old-fashioned, please and excuse sounds like two different things. Please excuse, parentheses, exponents. My dear sort of sounds like it goes together. And then also, Aunt Sally kind of sounds like it goes together. It's your Aunt Sally, so it's kind of together. My dear kind of goes together. And so it sounds more like 4 steps with the multiply, divide, add, subtract being together. So now, again, order of operations is for expressions. It's for when you have an expression with numbers in it and you're just trying to calculate it. So I'll put in here, when you're just trying to calculate something. But what we're going to be doing in this section is we're going to be doing some equation solving. Not real heavy equation solving. Don't worry, we're not going to do a lot of equation solving, but we're going to be doing a little bit. And when you're solving an equation, it's like this video that's being run backwards. You're trying to undo an expression and get back to where it was to start with. So when you're solving an equation, you're going to undo these things in reverse order. So we're going to use this idea of the order of operations, but in reverse order. So as we're over here with the rewinding the video, you're going to open the door, get in, start the car. When you're undoing that, when you're rewinding it, you're going to turn off the car, get out, and then close the door. So as you're solving the equation, if you see an addition, you're going to subtract. If you see a subtraction, you're going to add. You're going to do everything opposite of what it was, and you're going to do it in opposite order. Multiplication and division, you're going to do next, and you're going to undo a multiply, you're going to divide. To undo a division, you're going to multiply. Exponents, you're going to do a root to undo an exponent, and then parentheses, you're going to undo last. So let's see how this works with what we're doing. We don't have ones that are really long that have really all 4 of these steps at the same time. We're going to use this same formula that we had, and we have now Philip, who is 6 feet 3 inches tall, and we want to figure out Philip's BMI formula. Determine how much he would weigh for each of the following BMI values. Record your steps. So we're going to be given his height. We're going to put that in here. But instead of then being given his weight, we're going to be given BMI values that we're going to try to determine what weight he would have to be at that BMI value. So let's start by putting his, we'll work this over here, his BMI would be calculated by his weight divided by his height squared. Remember, height has to be in inches, so we're going to take 6 feet 3 inches and we're going to switch it into inches. So 6 feet times 12 inches per foot is going to give us 72 inches. And then the additional 3 inches will give us a total of 75 inches. So his weight divided by his 75 inches squared multiplied by 703. That would be then his weight divided by 75 squared, which is 5,625 times 703. We could get a single number for this by taking 703 and dividing it by 5625, but I'm going to leave it this way. So now we're going to put in these different BMI values. These are not obviously weights. He's not going to weigh 18.5 pounds. These are BMI values. So let me change color here and we'll put this in. So we're going to take, for part A, we're going to put in his, let me try that one different way. So I'm going to, for A, I'm going to put in his BMI value of 18.5. So 18.5 is his BMI value. Then I'm going to put everything else in the equation that we had. We know that the BMI is supposed to be his weight divided by 5625 times 703. So how are we going to get this weight figured out? Let me circle that. How are we going to get that weight figured out if we want his BMI to be 18.5? Well, we have to undo the things that are being done over here. So we have a multiplication out here that we're going to get rid of by a division. So I'm going to divide by 703. And then I'm going to, that'll cancel this. And then to undo this division of 5625, I'm going to multiply by 5625. So I'm going to multiply this by 56. I don't know why I keep writing that down wrong. Just a second. I'm going to multiply that by 5625. So I need to take this side and I need to divide by 703 because we multiplied by 703 here. And then I need to divide, or I had a division by 5625, so I need to multiply by that. So if I calculate that, 18.5 divided by 703, and then I multiply that by 5625, I get 148 roughly for his weight. It's 148.03, but I'll just say approximately 148 pounds. So 148 pounds is his weight if he wants to have a BMI of 18.5. And you could double check this by plugging it into the equation and make sure that you get back 18.5 roughly. So that's the first one. I'm kind of short on space here. Let me see if I can go over to the side here. So we're going to do the same thing, but I'm going to put in BMI of 25 now. So we'll scooch this over a little bit, and we'll do the B part, which is where we want a BMI of 25. And we want that to equal a weight divided by 5625 times 703. So if we want to undo this so that I can get the weight, I'm going to do the same steps I did before. We're just going to use the 25 here. So to undo the times 703, I'm going to divide by 703. I'm going to write it this way this time. So divide by 703, and we have 25 over 703 equals weight over, let's try to color code it the same way so you can follow a little bit more easily. So let's leave that 25 as red. So 25 divided by 703. This is canceled, and we only have on this side now weight divided by 5625. And to get rid of the 5625, I'm going to multiply by 5625. And that will cancel out the 5625 that's there. So multiplying by 5625 undoes a division. And so over here, once I divide this, I'm going to multiply by 5625. So 25 over 703 times 5625 should get me the weight. Okay, so 25 divided by 703 times 5625 will get me roughly 200 pounds. So it's 200.03. So I'm going to say the weight is about 200 pounds. Okay. So that's the second one. Now we have a third one where we want to be a BMI of 30. So in order for his BMI to be 18.5, we're at 148 pounds, just under 150. 25 is 200 pounds, and now we're going to be 30. So I'm going to go through this one a little bit more quickly. If you forgive me, I'm not going to do the color coding on this one. I'll just do it all one color. So we're going to start with 30 as our BMI. Times 703. To get rid of the 703, I'm going to divide. So 30 divided by 703. And that'll cancel. And I have W over 5625. To get rid of the 5625, I'm going to multiply since it's a division. And so I have 30 over 703 times 5625 equals W. And you notice it's the same process each time. Nothing changed except for this top number here. So 30 divided by 703 times 5625 gives us a weight of 240. So in order to have a BMI as high as 30, his weight is going to have to go up to 240 pounds. So now for Sally, Sally only weighs 115 pounds. That's different than this what we had for Philip here, because for Sally they're giving us her weight and not her height. So that's how it's going to differ from Philip's. For Sally we're going to be able to put in a weight, but we're not going to have a height to put in. So her simplified formula is going to be BMI equals her weight of 115 over whatever her height is squared times 703. Again, I could multiply these two numbers and just get one number, but I think I'll leave it separate because I think it's a little easier to see. So that's it for number 3. It says, what's her simplified BMI formula? How does it differ? It differs because we have the weight instead of the height. And it says that Sally has hit a growth spurt. 4 months ago, she was 5 feet 3 inches tall. Now she's 5 feet 6 inches tall. She's maintained her weight of 115. Find her BMI both 4 months ago and now. How much has it changed? And I'm going to pause for a second. I got to give myself a little writing space over here. So if you remember, 5 feet was 60 inches. We did that in the last section. So 5 feet is 60 inches. So 5'3" would be 63 inches. Again, that's just 5 times 12 gets you the 60 inches. And then add on the 3 inches. And that gives us 63. So her BMI 4 months ago would be 115 over 63. Don't forget it's got to be squared, times 703. So 115 divided by 63 squared, and then times 703. And that gets her BMI at roughly 20.4 for her BMI. Now, if she's grown from 5'3" to 5'6", that means she's grown 3 inches. So I'm going to use that knowledge and just add 3 inches here. So 115, add 3 inches, that gets us to 66. Square that height, and then take times 703. So if she's put on height, but hasn't put on any weight, then that's going to make her BMI go down. Because she's gotten taller and slimmer because she hasn't put on any weight. That's going to put her BMI at about 18.6. So now it says Sally continues to grow taller while maintaining her weight and eventually reaches an unhealthy BMI of 18. How does this problem differ from question 1 where you're given BMI values for Philip? And I wanted to mention too that I forgot to mention this earlier, so I want to go back and look at this. Over here it gave us healthy and unhealthy BMIs. It said if you were less than 18.5, you were underweight. Healthy is between 25 and 30, and then obese is over 30. So that's where they got these numbers when we were talking about Philip, and sorry I forgot to mention that. But basically what we calculated for Philip is that 148 pounds was as light as he should be to be healthy. If he went under that, under 18.5, he'd be underweight. 200 would have been the point where he was starting to be overweight. It said between 25 and 30 BMI is overweight. So he should be at least 148 pounds, but once he hits 200, he's considered overweight. And then our C, we were at 240 pounds. That would be where he would be considered obese. So 200 is overweight, 240 is considered obese. So now we're going to do the same thing here for Sally, but we have some different information. We don't have her height. We have her weight, and her weight is staying the same. So it's going to be a little bit different calculation because we're trying to figure out an unhealthy BMI of 18. So she's going to be underweight for her height. And then her weight is 115 pounds. We don't know her height, so we're going to put that in as an H. Don't forget to square it, times 703. Now, this is a little bit harder problem to do. And the reason it's a little bit harder to do is because of the two things about the H. First of all, the H is on the bottom, which makes it a little bit more difficult. And then the square makes it a little bit more difficult and gives us an additional step. We're still going to do the same first step. We're still going to divide by 703 on both sides. So once we go ahead and cancel these 703, I end up with 18 over 703 equals 115 over h squared. Now, this may not be the way that some books would show this, but my favorite method at this point, since this h squared is on the bottom, is to actually flip both the sides of this equation. As long as I flip the fractions on both sides, they should still be equivalent. So I'm going to flip both sides and make it 703 over 18 equals h squared over 115. What I can do then is I can then multiply by 115. That comes out to be 115 times 703 divided by 18 comes out to be 4,491.4. If I round it to one decimal place, that's h squared. And now what I want to do is I want to look for a symbol that looks like this. And I want to do the square root of both sides, because a square root undoes a square. So if I do the square root of this side, I simply get an h. And if I do the square root of this side, whatever I do to one side, I have to do to the other side. So multiply by 115, multiply by 115, square root, square root. So I take that number and I do the square root of 4491.4, and I get approximately 67 inches for her height. So if she were to reach 67 inches, remember 60 inches is 5 feet. So 67 inches would be 5 foot 7 inches. So if she reaches 5 foot 7 inches and she still only weighs 115 pounds, that would be considered to be a considerably low BMI, because remember they said underweight if you're less than 18.5. So if she's at 5 foot 7, she's going to have a BMI of 18, which is considered underweight, and a doctor would want her to put on some more weight. And how does this problem differ from question 1? Well, it differs in that we're looking for the H rather than looking for the W. I probably wouldn't put one like this on a test just because it's kind of tricky. But it's good to see that different things can happen. Having the W on top makes it easier, and then also not having the square on it makes it easier. So the H being on the bottom and the H having the square on it makes it more difficult, makes there be a lot more steps, actually 2 more steps to do. There is another way you can do this, and I'm going to back up and just kind of redo it. So I'm going to start from this step. If you don't like the flipping the equation over, you could also do this process. Since these are equivalent fractions, you could also do cross multiplication, and you could write 18h squared equals 115 times 703, which is 80,845. And then at that point, to get this h alone, you'd want to divide by 18. Some people like that a little bit better. Once you do that, you end up at this same step. You would get 4,491.4 equals h squared. So you would just kind of offshoot and do these two steps to get this instead of the flipping the equation over and multiplying by 115. So it's the same number of steps. One's not necessarily easier than the other. It's just whichever one you prefer. And I'm fine with either one.